All right, section 11.5, area and sector area. Really, really similar to circumference and arc length from section 11.4. An area of a circle should be review for you, right? We know the area of a circle is pi r squared. That's how we find it. So as long as we know the radius, we can find the area. So if our radius is 2.5, then our area is pi times 2.5 squared, or 6.25 pi, or 6.25 times pi is about 19.6. And if our units were centimeters, our area is centimeters squared. So remember, circumference, we're talking about distance, so we do not square our units. Area, now we are talking about a two-dimensional area, so we need to square our units. We can also use the area formula to find a missing dimension, like the diameter. This is the second example on this first slide. So we know our area is 113.1. and area equals pi r squared. Now, the problem is we're going to end up with our radius, not our diameter. But that's okay, because if we find our radius, we can find our diameter pretty easily. So we need to talk about how do we get r by itself. Step 1. We need to divide both sides by pi. So if I take 113.1 divided by pi, I get approximately 36. This came out nice and pretty for us. So if 36 is our r squared, that means our r is about 6. And if our area was centimeters squared, then that means our radius is in centimeters. But remember, we were looking for diameter, so if our radius is 6 centimeters, our diameter is 12 centimeters. Just like in 11.4, we used a proportion to find an arc length. We can use a proportion to find the area of a sector. Now, a sector, when I'm talking about a sector, I'm talking about if we were to take an arc on our circle and then basically cut out that piece of pie. That's the sector. So the sectors are like the pieces of the pie of a circle. And so it's two-dimensional, which is why it's area. And so the proportion is really, really similar to the proportion that we used before. But now we want area of the sector over area of the whole circle instead of length of a little segment over length around the whole circle like we did when we were talking about circumference. Because now we're dealing with area instead of dealing with distance. But the other side of the proportion stays the same. We want the measure of the piece that we're cutting out over the measure of the whole circle, which is always going to be 360 degrees. So for this particular example, this is slide 2. If I were going to cut out this little piece of pie, I'm cutting out 70 degrees. So that's the measure of the little sector we're looking at is 70 degrees. We want to find the area of that sector, and we do know the area of the whole circle. Well, it doesn't outrightly tell us, but it tells us that the radius is 8, and if we know the radius is 8, we can find the area by doing pi r squared. So 64 pi, or if I went ahead and multiplied that, we get approximately 201. We'll just call it 0.1 for good. All right, just like before, we're going to cross multiply to find the area of that missing, of this little sector right there. So 201.1 times 70 divided by 360. So the area of that little piece of pie is about 39.1. Our units here were inches squared. So the area of the whole circle was about 201 inches squared, but the area of the little piece of pie that we wanted was 39.1 inches squared. All right, we're looking at the third slide now on the back, and we're going to use this picture right here where we've got a little sector, a little arc of 120 degrees. We've got a radius of 14 feet, And the first question says, find the area of the circle. So area of a circle, pi r squared. Our radius is 14. So that's pi times 14 squared, or 196 pi. Or let's go ahead and multiply that out so it's easier later on. That's about 615.7. And our units are feet squared because we're talking about area. So about 615.7 feet squared would be the area of that whole circle. The next one says find the area of the red circle. It's not red for you. The red part is this part right here. The one with the 120 degrees. So we're going to find the area of that sector right there. So we know now the area of the whole circle is 615.7. We do not know the area of the part. We know the measure of the part is 120 degrees. And we know the measure of the whole circle is 360 degrees. And with this proportion, we're just going to cross multiply 615.7 divided by 360. We get about 205.2 feet squared. Last part says find the area of the blue sector. Again, you don't know what that is on your paper, but it's this side. All right, and so if this part was 120 degrees of the circle, then this part must be 240 degrees of the whole circle. So our proportion is going to look really similar. I'll call this one y instead of x, just for fun. Now we're dealing with 240 degrees out of the 360 degrees. And we can cross multiply to find that answer. And I get about 410.4 feet squared. But the other way to find the area of that sector, since we already knew the whole area was 615.7, and we knew this piece was 205.2, we could have just subtracted the two to get the blue. And this is off by just a little bit because of rounding, but really, if we take this piece plus this piece, we should get the area of the whole circle because those two pieces together make up the whole circle. So there's another example for you. Let's do one more of those. All right, so next example, really similar to what we've been working on. We're going to set up our proportion, but this time we know the area of the sector is 35 meters squared. We need to find the area of the whole circle. So our proportion is going to look just a little bit different. This time we know the area of part of the circle. We're looking for the area of the whole thing. We know that the part of the circle that we're looking at, or that we know, is 40 degrees. And of course we know the whole circle is 360 degrees. From here, we just cross multiply and we get that the area of the whole circle must be 315 meters squared. All right, let's try two more examples. I know this is really dark. My house has terrible lighting, and I don't have a lot of room to do this one, so bear with me as much as you can for the last two examples. But for this one, what we're going to do is we're going to find the area of the wall. And so here's the area of the painted wall. We've got this archway that's being cut out. So we want to take the area of the whole piece that we have there, but then we want to subtract out that archway because it's an archway, it's a door. We're not painting that piece of it. So if I want to find the area of the whole thing first, it's a rectangle. So our dimensions are base is 36 times height, which we can calculate by doing 16 plus 10. So our base is 36, our height is 26. So the area of the rectangle is 36 times 26, or 936. So that's our total area. Now we want to find the area of the archway. And that archway is made up of two pieces. We have a little rectangle right here that we need to find the area of. And we have a semicircle or a half circle right there. So let's start with the rectangle because that's a little bit easier. So the area of that little rectangle, we can see that the base is 16. And by looking over here, we can see that the height is also 16. Doesn't look like a square, but apparently it is. So the area of that little rectangle would be 256. So when we're all done with this, we want to subtract that from the total because we are not painting that piece. Now, we also want to subtract out this semicircle or this half circle. Because it's half of a circle, we're going to find the area of a circle, pi r squared, and we're going to divide it by 2 because we only want half of that circle. So our radius, we can see that the distance all the way across is 16, which means that our radius is 8. So let's go ahead and find the area of that half circle by taking pi r squared, or 8 squared, 64 times pi, and then dividing that answer by 2. And so the area of that half circle is about 100.5. So then the area of the whole painted piece, we would take that 936. We want to subtract out the area of the rectangle. And we want to subtract out the area of that half circle. So what's left is about 579.5. And our units, I don't have them written on here, but on your paper, I think it's feet squared would be the area of that painted part. So whenever you've got a cutout, right, because we don't know how to find the area of this little doodad unless we take the area of the whole thing and then break it up into pieces that we know and that we can take out of the area of the whole thing. All right, last example, we want to find the area of this shape right here. We've got a triangle and a half a circle again, so we're going to find the area of each piece. So the area of a triangle is 1/2 base times height. In this case, our base and our height are 7 and 7. We know that those are our base and height because they make a right angle. And so that would be 24.5 is the area of that triangle. And then we've got the circle, we've got half of a circle. So we can find the area of the whole circle and divide by 2, or 1/2 pi r squared. Our diameter is 7, which means our radius is 3.5. So we're going to take 3.5 squared, times pi, divide that by 2, and I have that that's about 19.2. And so the area of this whole figure, we would take the area of the two pieces, add them together, and get about 43.7. Our units were meters, and because it's area, we need to square them. So there's our final answer. That's how we find area of, we call these composite figures. Find the area of each piece, add them together.